We have 18 questions.
Okay.
A lot of them are multiple choice, which I'm loving.
Okay. Okay, and let's do number 3. In an ANOVA hypothesis test, we reject the null hypothesis when there is sufficient evidence to indicate at least one mean is different from the others.
Sorry, I'm so sorry. Okay, so
Since I don't know if you guys had time to review the video and stuff, you just want me to tell you what I think, and then you can look it up because I took some notes.
okay, I do have some. I do know the next. I know number 4, 5, and 6.
Okay.
But
the first one, in a ANOVA hypothesis test, we reject the null hypothesis when there is sufficient evidence to indicate.
Isn't that true?
It is true.
Okay.
If we not accept, but if there's sufficient evidence to keep the null hypothesis, that means everything is equal. They're all equal. You go to the alternate hypothesis when at least one of the means is different from the others.
Okay.
She kind of did this little cute thing about Sesame Street that said you accept the alternate hypothesis when you hear that little Sesame Street song that says one of these things is not like the other.
Oh. Mm-hmm. That's funny.
Okay, number 4. What requires? Oh, and before I forget, I told Cassie while you were at the door, Alexis, that I can show you guys and tell you how to look up stuff on Zillow or Realtor.com pretty easily.
Okay.
So we can get the information off that, okay?
Perfect.
We'll do that another time, but you were away when I told Cassie.
Sounds good.
Okay. What requirements need to be checked when performing an ANOVA hypothesis check?
I got B and C.
That's what I got. Okay, question 5. To check if each group is normally distributed, do the following. Scatter plot, histogram, or QQ.
Isn't it QQ?
Yep. Okay, number 6. We assume the variance in each group is the same if the following happens. The sample variance for each group is smaller than sample mean. The largest variance is less than 4 times the smallest variance, or the largest sample mean is less than 2 times, or each group has the same sample size.
I think it's B.
Yeah. Okay. Yeah, because the rule of thumb or the formula is the largest variance should be less than 4 times the smallest. So if the largest variance is 20 and the smallest variance is 5, well, that would be equal. If the largest variance is 20 and the smallest is 6, then 4 times 6 is 24. So 20 is less than 24.
Mm-hmm.
So that's the rule of thumb. My gosh, that chiming sounds like Big Ben.
I know. I'm at my parents' house for that bridal shower that I threw this weekend, and so they have a grandfather clock.
It was just loud. I make sure. Okay, and the ANOVA hypothesis test is equivalent to conducting independent 2-sample t-tests between every pair of samples. So if there are 3 samples, there are 3 pairs. So 1 and 2, 1 and 3, 2 and 3. How many pairs are there when there are 4 samples?
Oh.
1 and 2, 2 and 3, 3 and 4. 1 and 3, 2 and 3.
Do you have 1 and 4?
I'm gonna write this out real quick.
I think it's 14. No, it's 12. So if it was 4 samples, that would be 1 and 2, 1 and 3, 1 and 4. And then for 2, it'd be 2 and 3, 2 and 4. Three and 4. 1, 2, 3, 4, 5, 6.
I think it's 7. No.
Think,
No,
well,
you're
tell
right.
me what you think that.
No, you're right. I think you're right.
1 and 2, 1 and 3, 1 and 4. And then go to 2s.
3, 2 and 4. And
2
3.
and 3, 2 and 4. And you go to the 3s, 3 and 4. It's because we already have 3 and 1.
Yep.
Oh, no, wait a minute. And we have 3 and 2.
Mm-hmm.
We don't need 3 and 3, 3 and 4. 1, 2, 3, 4.
Yeah, I think it's 6. You're right.
I think. Huh. I don't know.
See the 4 and 2 says like, oh, we need 4 and 2. But then I was like, no, wait, just kidding. We're good, I think.
Oh, wait, I didn't do the 4s. Well, we already have 1 and 4. We already have 2 and 4.
And we're at 3 and 4.
Okay, so maybe it's 6. Okay. Let me pull this stuff up on.
Soccer shoes.
Okay.
What are we looking for?
What is the minimum variance for the 6 groups?
I mean, what's the name of the file?
Oh,
Soccer shoes.
soccer shoes.
Oh, soccer shoes. Okay. Sorry, I'm trying to find it. Oh, okay.
Sorry.
Soccer shoes. Okay.
Minimum.
Do we have to do a automatic recode?
Yeah, I wrote down the whole entire rigmarole. So what you have to do first, there are 2 things you have to do first, which is to find out if they're normally distributed, because she said like on the test, that might be where they trip you up. So let's just see. The data was collected to help determine how the design of a soccer shoes affects the accuracy of a kick. 5 types of shoes, and also just wearing socks for a total of 6 groups.
Mm-hmm.
Each row represents a kick from 10 meters away from a target that was hung 115 centimeters up from the ground. The column accuracy is the distance in centimeters from where the ball impacted the target to the center of the target. So smaller numbers are more accurate. Okay, so we have, yes, we need to recode. So you go to, there's a couple different steps here. Go to transform, auto recode. Okay, and then it says transfer the name to the right that needs to be recorded, or the coded into number instead of words. So we need
Maybe footwear.
well, no, because Oh. Yeah, footwear. Because it is in words and we want it in numbers. And then you put the new name, which would be, I don't care. I'm just going to do footwear. Oh, I guess you have to change it. It can't.
Just put number. I put the number sign at the end of mine.
Oh. That's a good idea.
Pound.
Okay. Okay. Okay, then you go to the next step, which is analyze, compare means. Then you go to the one-way ANOVA. Okay, and then it says, tell SPSS what you were measuring. We are measuring the accuracy, right?
That's in the dependent list, right?
And the dependent list.
And then our new name and a factor.
And then the footwear number and the factor. And then you push options.
Oh, shoot.
Are you there yet?
Mm-hmm.
I already went and did it. There we go. Options. Okay.
Okay. Options, and you click on the box at the top that says descriptive, and you click the box that says means plot.
And then continue.
And then continue.
And then okay.
And then,
There we go.
I guess, and then okay. Here we go. Okay. Now, where this is the difference of this is because there are two different degrees of freedom. See it where it says ANOVA, and it says sum of squares, and it says DF, that means degree of freedom. So in multiple comparisons of means, you'll have 2 degrees of freedom, a high one and a low one. Okay. So what is the minimum smallest variance for the 6 groups? Okay. So when you go up to that, when you go up to the top one, it says descriptives. Do you see that?
Mm-hmm.
Under A, under the means, it says 33.10, 32 point, and you're supposed to put in what's the smallest? Is that what it asked you? Is that what it's asking?
Minimum variance.
Yeah, what's the smallest variance?
Well, wait a minute. On hers it said variance. You know, we're missing a step because we're supposed to put in, weren't we? The groups, but I guess it doesn't matter because they're already in groups of A, B, C, D.
Mm-hmm.
But wait a minute. When she did it before, there was a thing that said variance. Well, let me see if I can find it.
I'm looking at the instructions but I'm not seeing anything that we missed.
Okay, you know what? We may have to check. Well, no. Okay, so
How to find the variance using SPSS.
yeah.
Select menu item, analyze, descriptive statistics, explore.
Oh, did she put it into explore?
Analyze descriptive statistics. So.
Oh, wait a minute. Okay. to find the variance, click on the QQ plot, go to our original thingy, output,
Okay.
analyze, descriptive statistics, and explore. Put item in dependent list that we're trying to, so I think that's accuracy. And then the factor would be footwear. And then hit the plots button and hit right in the middle. It says normality plots with test. Hit continue. And you can push plots. Oh, I already did that. And then okay. All right.
Wow.
Now I see the variances, I think.
Where?
Okay, right in the middle. Okay, the first one under footwear, the first one says case processing summary. Do you see that?
Yes.
Do you see that, Alexis?
I'm still working on the other step, but you guys can keep going.
Okay, do you, Cassie, do you see where it says case processing summary?
Mm-hmm.
Okay, the next one down says descriptives.
Yes.
And so under footwear for A, the variance under A.
27.330.
Uh-huh.
Perfect.
And then the variance under B is 29.484. And the variance under C is 27.208. Variance under D is, ooh, that's a big variance, 53.185, and under E is 31.011. And then under socks, 1, 3, 4, because we have 6 variances. Under socks is 40.724. So it's asking for the smallest variance, right?
That one's C, right?
27.208.
Mm-hmm.
Okay. No, wait a minute. It's asked for the, oh yeah, sorry, that's number 8. 27.208. The largest is 53.158.
Yep.
The test for equal variances is satisfied for these data.
This is where you do the at the smallest, right? Times
Oh, okay.
however many there are.
Yeah, so the largest, 53.158, has to be less than 4 times the smallest, which is 7. Okay, so 4 times 27.2, whoops. 4 times 27.208 equals, okay, so it looks like the variance is smaller, so it would be true. Okay, then construct a QQ plot for each of the 6 samples. Each of the samples are approximately normal based on what you see in the QQ plot. Okay. Okay, do you know how to do that? A QQ plot? Oh, okay, the QQ plots are at the very bottom of that output.
Yeah.
and they all look normally distributed because
Yep.
they're all in a line. Oh, wait a minute.
What's that last
No,
one
they're
though?
not. That last one is not.
Neither the last three. I think the last five. Whoa, there's a lot of them.
Oh, okay, wait a minute. Okay, do you see where I think it says, see where it says normal QQ plot for kicking accuracy?
Uh-huh.
Okay, and then, so they're all kind of in a line until we get down to
The detrended normal. What's that?
detrended. And I don't think we're doing anything with that.
So I think that it does look normal
I think so too.
because they go through all of them, each of the different styles of footwear, and they all look normal.
Okay. Okay, then perform an ANOVA test in SPSS and observe that the p-value is 0.081. Then remove the SOX data and perform the test again. What is the p-value? Yikes. Okay.
So basically we have to just go back to the original page, delete the socks ones, and then try it again?
I think so.
I don't know how to just go in there and delete.
Okay, I think what you do is when you group them, you just don't put that. I think you just don't put E in. Oh, you just don't put socks in. Oh, unless it'll let us delete them.
I don't.
Oh, it did. It let me delete. Oh, no, it didn't. Okay, so go to analyze. Actually, I'm going to get completely out and try doing it again so I'm not so confused. Okay.
Oh, nice.
Okay. Ah, shoot. Okay. I'm going to open. Soccer shoes. Because it seems like we have to group them. So we group them. Remember how the last time we had to put them in groups?
That was for a one sample or the two sample t-test or whatever, where we could actually like go in there and put what groups we wanted, right?
Yes, but I think it's the same way this time, I believe. But okay. Transform. I'm going to try this again. Transform. Auto recode. The variable is the
I found a way to clear all of those. You just hit control and then you click on the farthest little box on the left that just says what line it is, and you copy it and you hit control and then just click all of them going down. You can hit clear and it will disappear. Yeah, and then it just takes the socks one out. And the p-value is the sig, right? You're muted, Lori. Hey, Alexis. Lori. Ah, sounds good.
Hello, can you hear me?
Yes, we can hear you.
My phone totally died,
Uh-oh.
and my microphone on my laptop, something's wrong with it. It has been for about a month. Okay. Sorry.
You're good.
I had no idea it was that close to being dead. But I got it plugged back in. Okay. So the variable we want is the footwear, right?
Mm-hmm. Did you figure out how to go in there and delete those?
That's what I'm trying to do right now.
If you go in and you hit control and then you just click on the far left numbers that says like what line that information is on, it'll highlight it, and then you just keep on clicking all the way down, and it'll say like a little box will pop up and it'll say clear, cut, copy, or whatever. If you hit clear, it just deletes all the.
Okay, let's see. So I highlight footwear.
Not all.
Number the new column.
So I went down, like I scrolled down all the way to 101, which was where that the socks information was at.
Oh.
You see what I mean?
Oh, okay. I already deleted it.
Oh, okay. Good.
I must have. It's gone. All I got is A, B, C, and D, and E.
Great. Well, then you're already good.
Okay. So then, what's it asking?
For the p-value.
Okay. So then we go into analyze, compare means, one way, ANOVA. Dependent list is the kicking accuracy, right?
Yes.
Footwear is the factor. Okay, did you guys put in the options and all that kind of crud?
I didn't because I forgot.
Okay, so the p-value is 0.309?
Yes, that's what I got.
Okay. Okay, gosh, that was annoying. Okay. The test statistic for a ANOVA hypothesis test is an F statistic. Is the p-value the area to the right or to the left of the F statistic? Okay. It's to the left, right?
Is
that what she's talking about?
I think.
No. Is the p-value the area to the right or the left of the F statistic? So it would be to the right.
Yeah.
Okay.
I got that backwards.
Okay. Ugh. Now we have another. Researchers at Consumer Reports analyzed these types of hot dogs, namely beef, poultry, and meat. Mostly pork and beef, but up to 15% poultry meat. Blech. For each of the 54 hot dogs analyzed, they recorded the type, the calories, and the sodium level. Their data is in this file. Use this data to answer the following questions. Okay. Did you guys already bring this up?
I have it brought up, but I have to go and automatically recode all that junk.
Okay.
Is it type in the variable or is it?
Yeah. I put just type number. I always just put the pound sign afterwards.
Wait a minute. What's the name of that file? Isn't it hot dog?
Hot dog nutrition.
DASL hot dog nutrition.
Oh, DFL.
DASL hot dog nutrition.
Oh, okay. I lost it. Sorry. All right. All right. So then we go through our steps, right? Are you going to do the recording? Are you going to do the recoding first? Or are you going to go through that QQ plot thing?
I think you have to automatically recode it first, don't you?
Well, not according to the video she did, because I wrote down my notes as she went along.
Oh.
And the first part I wrote down was that analyze, make sure it's going to be a valid test by looking at the QQ plot.
Mm.
And she made a note of saying that be careful of looking to see if it's normally distributed first. So I'm going to go to analyze, descriptive stats, explore, put in the dependent list, which is what you're measuring. What are we measuring?
This one has a lot of numbers. Are you measuring calories or sodium or both?
Okay.
Ooh.
Okay. Oh,
I would say that the calories and the sodium are in the dependent list, and then the factor list would be the type, right?
yes, because the dependent list is what we're trying to measure.
Mm-hmm.
Oh, do you see where it says label cases by?
Mm-hmm.
I wonder. Oh, I guess she didn't tell us to do anything with that. Okay. So then you go to plot, normality plot, continue, and okay.
Wait, what? How did you do that?
Okay, you go to the plots button.
And then click normality.
Wait, the
And then
plots
click
button.
plots button is over to the right. You see it?
Shoot, I think I might have skipped a step.
Did you go to?
Oh,
did you go
got
to
it.
analyze? Okay, you find it.
Yep.
Go to plots.
Mm-hmm.
Okay, and then down at the very bottom is where they have the QQ plot,
Mm-hmm.
and it looks like they're pretty normally distributed. Oh, yeah, they're pretty normally distributed. I think you don't look at the detrended normal QQ plots. I think you just look at the normal QQ plots.
Yeah.
Okay, and then you look at the variances under each color. So we write that down, or under each type, rather, I mean. So
Mhm.
under calories, the variance is 512.661. And under meat, the variance is 636.846. Under poultry, 508.566. And under beef is what?
What did you get for the meat, for the one under meat?
636.846.
Okay, just
I
checking.
think I'm looking in the wrong area.
Oh, you know what though? There are two different.
Yeah, so there's the sodium and the calories that were measured.
The calories are, the variances on the calories are
So it's calories for beef, calories for meat,
meat,
calories for poultry,
poultry.
and then sodium for beef, sodium for meat, and sodium for poultry.
Where did you guys find the variance?
Do
Oh, I
you
see it.
go to the very top? Yeah, it's
I see
under descriptives, and it's in that gray boxed area.
Okay.
Okay, then the sodium for beef is 10492.871.
Mhm.
And then for meat, I don't even know if we need this, but we might. And then for poultry, 7180.750. Okay. So what's our first question?
Examine the calories first. Construct Q plots of the calories for each of the 3 types of hot dogs and compare the variances to determine the assumptions of the to use ANOVA have been met.
Okay. So let's examine the calories first. Construct QQ plots of the calories for each of the 3 hot dogs and compare the variances. Determine if the assumptions to use ANOVA has been met. So so for the calories, you take the lowest times 4 times the highest. No, I said that wrong, right? You take the highest. The highest needs to be less than 4 times the lowest, and it is.
All right, so
the assumptions have been met.
Is A, yeah.
Well, but both A and B are the assumptions have been met. So it's safe to assume each group comes from a normally distributed population from the QQ plots, and we can assume that the variances are equal. Or while it is safe to assume each group comes from a normally distributed population, we cannot assume the variances are equal.
Oh.
I think this is just my opinion. I'm going to put this, and you guys can, put something else. But I think we cannot assume the variances are equal because we haven't done the t-test yet. Or we haven't done the test yet. Run an ANOVA test to determine if the mean number of calories is the same for all 3 types of hot dogs. You should find that the degrees of freedom are 2 and 51. That F equals 16.074 and P equals that with a level significance of 0.5. Okay, so I'm going to go do one of those NOVA tests. So I'm going to go to Analyze, Compare Means, One-Way NOVA, the dependent list. Ugh.
Didn't we just do that though, the NOVA test?
No, we did the QQ plot though.
Would it be calories and sodium for the dependent?
Yeah, I think so. But we have to have a factor too.
That would be the type number.
Oh, I haven't. Oh, you know what? That's because I have not recoded it yet. Okay.
Run an ANOVA test to determine if the mean number of calories is the same for all 3 hot dog types.
Okay.
I don't think that they're the same.
Analyze, compare means. One-way NOVA. Dependent list is calories and sodium, and that is the factor. Okay. I think I have it. What did it say that the F test was? What was the number for it?
What?
In the question itself, it said the F number is
16.074.
And the SIG is what?
0.
Okay. Do you guys have that yet?
Yeah.
Did you find the table that shows it?
Yeah.
Yep.
Okay. I'm behind then.
Bless you.
Thank you.
Okay. So then it says,
PCR runs for this with you drop.
Oh, yeah. And then it says, run a ANOVA test to determine if the number mean of calories. Well, we know it's not. And the p-value is 0.0. And the level of significance is 0.5. And 0.000 is less than 0.05. So the p is low. The HO must go. So if the P is low, H is low. So we
have sufficient evidence to claim that all 3 hot dog types have different mean number of calories.
So we reject the null hypothesis, and we have sufficient evidence that to claim that all 3 hot dog types have a different mean number of calories. Or we have sufficient evidence to claim that at least one of the hot dog types is a different mean number. I think it's at least one. Because we don't know if they each have something different. Okay, let's examine the sodium levels. Construct a QQ plot. You should see that the QQ plot for poultry suggests a possible problem with the normality assumption. The smallest variance is that, and the largest is that. Have the assumptions been met? So the smallest is 7.1. Oh no, so the largest is 10,492.871. Is it smaller than 4 times 7? And is not smaller. Yeah, it is.
Yeah, it is.
So the assumption should have been met. The assumptions have been met. Okay to assume each group comes from a normally distributed population. I think it's the first one. They have been met, right?
Mm-hmm.
Because the largest number is smaller than 4 times the smallest number.
Yeah.
Oh my gosh. Okay. Despite the possible problem with the QQ plot for poultry, you decide to use ANOVA to determine if the mean sodium levels are the same for all 3 groups. What is the p-value for this test? Okay.
So now you have to go in and do the Q plot again.
The Q plot for just the hang on, it should show the Q plots. Okay, see down below it says Q plots of calories.
For sodium though?
I'm looking. Okay, and then all the way down it says normal QQ plot of sodium.
Yeah, I see it.
All the way down kind of towards the bottom.
Yeah.
Okay, so what's the question?
What's the p-value?
Oh, what's the p-value? Oh, crud. Okay, so the p-value for sodium, it's all the way down to the very bottom, 0.179. Do you see it at the very, very bottom?
Oh, yeah.
So what conclusion can you draw about the mean sodium levels?
Wait,
So,
what? Well, it was 1.179.
Yeah, do you see it all the way down at the very, very bottom?
I actually see it up there in the ANOVA test. Where it
Oh,
says
okay.
between groups, but
Okay.
I was just making sure it was right.
Okay, so what conclusion can you draw? Well, 0.179 is greater than 0.005. That's the p-value. So if the p is high, you keep the guy. which means we have insufficient evidence to claim that all 3 hot dog types have different mean sodium levels. Oh no.
So wouldn't it be B?
We have sufficient evidence to no, because you want to keep the guy.
We do not have
If
sufficient
the
evidence.
P is high, you want to
reject
keep
the
the
claim.
guy. You want to keep the null hypothesis, which means you.
I think it gets confusing with that. We do not have sufficient evidence. We have sufficient evidence, but B made sense to me. Because we're not rejecting it, right?
Should we just guess an answer?
I think B was right, but I don't know. Now I'm all confused.
I know. Me too. I guess we could just try since we have 2 tries.
Yeah. There's like 1 left. I would do it.
Yeah.
We go to submit quiz, submit quiz. I got a 95, so I only missed 1.
Oh, sweet.
Oh, I think it's question 14 is the only one we missed. Are you still, did you turn yours in or are you still on it?
I'm still on it.
Okay, so 14 is the question that we got wrong.
14?
Yeah,
Okay.
so we got that last one right. Go, sweet.
So that one's B then?
Yes, that one is B.
Okay, 14 have not been met. Oh, man. It's not, would it be D?
Okay.
Yeah, I would say that would be D.
All right. You guys will not believe this. Sorry.
You're fine.
I actually had to take that call because as a real estate agent, I have, oh my gosh, this has never happened to me in 17 years. I had an inspector with the client at the house and the house caught on fire.
Oh my
No
God.
way.
Yeah, it's like up in flames.
What happened?
Well, the homeowner turned on the air conditioner, which I guess was faulty, and they were up in the attic looking at the wiring, and the inspector said, "This is faulty wiring. I'm surprised it hasn't caught a fire." And he went downstairs and was in his car and looked up, and there was smoke coming out of the air conditioner disconnect unit.
Holy cow.
Oh my gosh.
That is insane.
Yeah. Okay, sorry guys. What did we get for number 18? We keep the guy.
It's B.
So we do not have, okay. I'm going to have to get off here really, really fast. That's 18. Okay, I have to get off of here because I'm going to have to handle this problem.
So 14 is not D, Cassie.
Uh-oh. Did
It's
somebody
not.
submit it?
Okay, so 14 is not B and it's not D.
Okay, hang on. I just was going to submit this. Let me go back. Oh my gosh. Oh my gosh. It kicked me totally out of the quiz.
Oh.
Oh my gosh. Hang on.
So it's not B and it's not D.
Okay, so is number 3 is true?
Yes.
Number 4 is B and C?
Yes.
Number 5 is C?
Yes.
Number 6 is B?
Yes.
Number 7 is 6?
Yes.
Number 8 is 27.208?
Yep.
9 is 53.158?
Yep.
10 is true?
Mhm.
11 is true?
Yep.
12 is 0.309?
Yep.
13 is right?
Yep.
14 is B? No?
No.
So
And
it's not it's not B or what?
D.
It's not B or D. So the assumptions have not been met. It's safe to assume each group comes from a normally distributed population, and we can also assume the variances are equal. It is safe to assume each group comes from a normally distributed population, but we can assume the variances are equal. Isn't that the same questioning? Same wording?
We thought that the assumptions have not
It is.
been met.
Okay, it's not safe to assume each group comes from a normally distributed population, but we can assume, I think maybe it's A.
A.
I think.
Okay.
I'll do mine in a second. 15 is D.
Yeah.
16 is A.
Mhm.
17 is 0.179.
Yep.
And 18 is B.
Yes.
Okay, I'm gonna submit my quiz. And I got 100%.
Perfect.
Okay.
So it's
So it's A?
Pardon?
It's A?
For number 14?
Yeah.
Yes.
sweet.
Okay, I gotta go find out about this fire.
Good luck.
Bye.
Have fun.
Bye.
Yeah.